Hi, AP Chemistry students. We're going to be talking about the ideal gas law today. It's a hypothetical law that involves gases that are ideal, and we'll find out that gases do deviate from the ideal gas law later on in this chapter. But the formula that we're going to use for this ideal gas law is pressure multiplied by volume of a gas is equal to the number of moles of gas multiplied by R multiplied by the temperature. Let's talk about each one of these variables really quickly here. We'll start off with pressure. We need to make sure that whenever we're doing a problem involving ideal gas law that we have our pressure in atmospheres. For volume, we want our units in liters. N is going to be the number of moles of a gas. R is the ideal gas law constant. We're going to use a couple different constants. The most common constant that we use for ideal gas law is the constant of 0.0821 units are liters multiplied by atmosphere divided by moles multiplied by Kelvin. This is the reasoning behind using ATM all the time in our pressure conversions, even though we talked about before you can have pressures in torr, you have pressure in kPa, you can have pressures in millimeters of mercury, but you always want, if you're going to use the ideal gas law, you always want to make sure you have your pressures in atmosphere. Temperature is going to have a unit of Kelvin. Just like we said before, we always want to convert all of our temperatures to Kelvin for gas law problems. So that's the formula, PV equals nRT. It's the ideal gas law. It's very, very useful for the big reason is it involves moles of gas, and that's why we use it in AP Chemistry so often. Let's give you an example of what we're talking about here. I'm going to go ahead and scroll down, give you an example of a problem involving this. Okay, so we have 2.5 liters of gas being heated to 50 degrees Celsius. We have a pressure of 800 torr, and we're being asked to calculate how many moles of gas are present. So once we see that moles involved, we're going to be thinking ideal gas law. So we have PV equals nRT, and we're given all of these variables, or one of them is a constant. We're just going to solve this guy for the number of moles, because that's what we're after. So N is going to be equal to pressure multiplied by volume divided by ideal gas law constant multiplied by temperature. And so let's go ahead and plug some of these values in here. So for pressure we have 800 torr. Now what I'm going to want to do is I need to convert 800 torr to ATM because my ideal gas law constant deals in ATM. So I'm going to go ahead and set that up right here, 760 torr. Just like that. I'm going to multiply that value by the volume, which in this case is 2.5 liters. Then I'm going to divide it all by the ideal gas law constant, 0.0821 liters atmosphere moles Kelvin, which is then going to be multiplied by the temperature, which is 50 degrees Celsius. And so, and it's really, we got to make sure that we add 50 degrees Celsius. I mean, we're going to add in 273 degrees to get us to Kelvin, which is going to give us an overall answer of 323 K. That's the actual value we want to use there. So I just wanted to put that there so you saw what I did. So let's run this through our calculator and see what we come up with. So when I run this through my calculator, I'm coming up with 0.0992 moles of gas. Not very many moles of gas. going to give you one more example here for the night, and this one is going to be we're looking for a volume of a gas will occupy, what volume of gas will occupy if we have 1.75 moles of this gas with a pressure of, we'll call it 0.985 atmosphere and a temperature equal to -6 degrees Celsius. Okay, and so there's our problem. So again, this is going to be a ideal gas law problem because we're involving moles. PV equals nRT. We're looking for volume of a gas, so we're going to go ahead and divide both sides by P. We're going to just plug some numbers in here. We have 1.75 moles. We're going to multiply that by R, 0.0821 liters atmosphere mole Kelvin, multiplied by temperature. For temperature, we have -6 degrees Celsius, which we got to make sure we do the proper math there. We get 267 Kelvin. We're going to divide the whole thing by its pressure, 0.985 atm. Just to double check here to make sure we've done everything correctly, we want to go ahead and cancel some of our units out. So moles cancels with moles, atmosphere and atmosphere, Kelvin and Kelvin, and so we're left with an answer in liters, and that's what we're looking for. So we've converted everything to the proper units. And I ran that through my calculator, and I'm coming up with 38.9, and our unit is going to be right there. It's liters, and there is our answer. I just want to double check that. It seems a little high, but double check that really quickly. 0.0821 multiplied by 267 divided by 0.985. Yep, it checks out. Okay. Hope you guys have a good weekend.